Uh, let's talk about control flow statements. So control flow statements, we'll be starting with if statements. So basically control flow statements means that in any part of the program, if you want to alter the flow of statements in which the script executes, we use conditional statements or loop statements or break statements and try except statements to break the flow of statements and continue in its own conditional way. So the most important control flow statements are conditional statements and loop statements. So let's look into each one of them. So conditional statement is Python uses if statement to does this. So it's pretty simple. So you basically have to pass some condition. If that turns out true, the code of block will be executed. If it's false, it will be skipped. That's a simple if statement. So we can execute one operation. Here x is greater than 10, so it's going to print out hello. So else statement is a control statement where else part would also get executed. In Python, we write the if statement with a condition and followed by a colon, and the else statement would. So you, as you know, the important part about this thing is that indentation. So Python cares about indentation a lot. So anytime you write, it's just not like a set of statements you write in a same indent. You have to use some kind of indentation to say it has to go inside that block of statements. So if you use a less indentation and if you align the indentation with the different, so when you execute this, you would get a so you would get a expected and indented block. So basically it says that if whatever goes inside, if you need to get indented with whatever indentation you have planned to do. So we'll cover about all these structures and indentation in the Python style guide that we will be seeing in other chapter. Okay. So else statement is if a condition goes wrong, the else part of the statement would be executed. And there are other style of statements, is like you can do a nested, or you can have a if statement, and nested are basically you keep on having the elif statements. You form one more if, and else you form one more if, or at the end you will have else somewhere in the code, and you will be having structured if else statement if inside one more if. So it's just like any other language you'll be coding. Okay, that's about the control statement using if, and there is no switch in the Python. So all you can write a switch using the dictionary where key value pair you can compare, and so you can think about how to write a switch statement in Python without using without using actual switch constraint, using just the dictionary approach or some other approach. You can just find out that you can take it as an assignment. So loop in Python, basically just like any other languages, it will have a for loop, and it has a while loop. So for loop is actually, it's not index based, it uses something called as iterations. So it's basically a for each in any other languages. So how you write is, so let's say you want to iterate to iterator called as list or tuple. Say so for example, we have given a string, you are going to iterate through each character and print out the string. So this is how it's going to work. So or else you can do with one more approach. So say let's take an example. Okay. So we often tend to use a range when we want index. So if you want to have an index, you do something like a range of a particular value. So what it would give a iterator having a index from 0 to 4. So when we print out, so if we just print out here, along with the total. Let me print out the index as well. I run it, so I'll get all the indexes over here. So see, I got 0, 1, 2, 3, 4. Along with that, there we are finding out the total, like adding each and one of them. Basically it's n into n minus 1 by 2, so that would give 5, 6 into 5, that's 20, 30 by 2, so it's 15. I think we're going to add only 1 plus 2 plus 3 plus 4, so that would be 5 into 4 divided by 2 by 4, so 20. Okay, I'm missing something. Okay, whatever. So we are basically calculating the sum. So 1 plus 2 plus 3 plus 4, so 7, 9, 11. Yeah, let me run it again. I think we are just okay, so sorry, this total is not the total of this, so it's basically we are finding out the total of, we are not printing out the total here. Let's print out the total if you want. Okay, so I have printed out the total here. So this is basically, yeah, so the total of all the integer, but this total is basically we are printing it out for I comma j, so that's it's going to give 1 comma 2 and 1 and 2 initially, so it will be 1 into 2 and it will be 1 to the power of 2 and 3 to the power of okay, missing out something. So whatever, you can look into that later. So it's basically it gives out the total of 14. So this is all about the looping structure. So, and if you want to see how the two-dimensional looping works, it's the same thing. So it's a list of lists. So you can form a matrix using the loop. So what you do is you print out all the rows. So you say this is a list 1, list of list. You print out the first list and second list and third list. And if you want to print out the element again, you can have one more loop inside that. Let's write it down for ELE in list 1. Print, yes, it's indentation ELE. So now it's going to print out all the each and every element for the row as well. So this is how the for loop works in general. So you can do a lot of other operations, such as you can reverse it and then print it. So whenever you form a list, this is all this is how you form a list for iteration. And this you can, there's another operation called as enumerate, where it returns the index and the character. So you can just print it out that as well. So this is an index along with the character, so you can use that. And you can use any other operation which basically gives out a list as an, or an iterator as an object over here. So zip is also, it gives out an list of tuples as an response. So and one more thing, so which is like rarely used, or in some places which may have so where you don't have an iterator, you tend to use a while loop where you know a fixed number of loops. So you have an index, so you basically iterate to that many index, and this is how the while loop works. And there are some operation you can use, some of the statements such as break. When some condition occurs, you can just break it. You don't know the exact when it's going to end the loop, so you can have a break, so that whenever it is, so for example, you can either write I, and you don't know the range. Maybe you can have a while loop for this. So basically you can also replace this live while loop with a condition, or you can have an iterator where having a condition and using a break operations. So continue is a similar thing. The thing is, you want to skip some of these operations, you just continue with the loop rather than breaking it. So the catch. Okay, so this is one more control flow control structure. So the last one, control flow statement that we are going to use is the try catch and this try except. And this you will often see in any of the programming scripts or on projects, that Python always we implicitly writing any condition, we catch the exception and try to raise the error. So the simplest example would be, you try some part of the code, and if there is an exception, you say you don't want to abruptly end it, you do some of the exception part handling, error handling part, and then you quit the script or whatever set of statements. So you can write a while statement, and whenever you can also raise an exception. So raising an exception is nothing but you have a particular exception which is defined, and you can catch that exception, and this set of exception can be a predefined which is already there in a Python library, or you can create your own exception on top of any other exception and you could handle it. So Python, anytime it sees and raise of any kind of exception which you have defined, it will quit this execution and come to the exception part. So for example, after the count of 3, like it will go to the 0, 1, 2 and 3. We are just raising an exception here. So if you make it like a 5, you would see the same thing. After the 5 you got an exception, and the same thing could be you can have other kind of exception. So you can also, so this you can also see what kind of exception, like you can write just abstraction as e. So this would give out what that particular exception has in message. So you print out a string of e. So you would see float division by 0, which is not allowed. So this is a divide by 0 exception. So this is how you handle an exception, and this is how it alters the control flow of a program. And this is all about the control flow statements in Python.